Hi everyone, welcome to IGNOU's classroom. In this video, we will be discussing about a few important questions and how we can answer them based on the questions we have observed from the past year's question papers. So, MMPC 5 is almost having equal importance to theory as well as practical. We have two sections in this. There is a section A which carries 15 marks per question and a section B which is compulsory and carries 40 marks. So the usual structure of section B, it will only have two questions. One would be a practical question, a mathematical problem, whereas the other second question would be a theory one. And the section A, you will have choices. In that also, you will have at least one or two practical questions, and the remaining will only be theory. So over here, you need to know how to solve the problems as well. So I went through the past year's question papers and I've taken a few questions from it which were repeating. So you will be able to find at least one or two of these type of questions in your examination paper, in the next examination paper as well. That is what I am assuming. Okay, so one of the questions which I have seen getting repeated over and over is they will be giving you two variables. Okay, the variable names might differ. This is x and y. Sometimes it will be some other names given. Okay, but you will be given two variables or two set of values, data sets, and you will be asked to find the coefficient of correlation. So generally when we are asked to find the coefficient of correlation, it is most easiest one to find out is the Pearson's coefficient of correlation, okay, or Pearson's correlation coefficient. You need to know how the formula of it. So the formula of this correlation coefficient, let me write CC for now, is n times sigma xy minus sigma x sigma y divided by root of n times sigma x square minus sigma x whole square, okay, multiplied by root of n times sigma y square minus sigma y whole square. So this formula you have to study and go. So from this, n is the number of samples. We have 1, 2, 3, 4, 5, 6, 7, 8, 9 samples. So n is 9. Now we need to find sigma xy. So that means we need to multiply x and y together and we have to write down the answer. Okay, so xy, let me write down quickly. Let's note it here. Okay. Now we need to find the summation of it. So if we sum up all these things, we will get around 731. Next, we need to find out the summation of x. So that comes around 45. Summation of y, it comes to be around 135. Okay. Then we need to find x square sigma. So x square, I'll write it down over here itself. Okay. That will be 1, 4, 9, 16, 25, 36. Okay. The summation of this will be 285. Similarly, we need to find out y square. I'm writing it over here, okay, here itself. And its summation will be coming to, okay. Next, what do we need? I guess we have all the values. Okay. So now we can apply in our formula. 9 into sigma xy is 731 minus sigma x is 45. Okay, this is sigma xy. This is sigma x. This is sigma y. This is sigma y square. And this is sigma x square. Right? Okay. So 45 into 135 divided by root of 9 times sigma x square, that is 285, minus sigma x whole square, that is 45 square, times 9 into sigma y square is 2085 minus sigma y's whole square, that is 135 square. So that will come around 504 root of 540 into root of 540, that is 504 divided by 540. So when we do that, you will get the answer as 0.933. Now, according to the rules of correlation, if your correlation coefficient, that is this one, is between 0.5 plus or minus 0.5 and 1, it is high correlation, right, or strong correlation. If it is between 0.3 and 0.49, because from 0.5 it is in high or strong correlation, it is medium or moderate correlation. And if it is anything less than 0.29, then it is very low correlation, right? So according to this rule, these two variables x and y are strongly correlated or very high correlation exists. So this is how such a question has to be answered. So please learn this formula by heart and go. The past 2 years, the last two terms, we had questions related to coefficient of correlation. Even in the previous years, in the old syllabus also, we used to have coefficient of correlation question. So I'm hoping, I'm betting on such a question might come. Okay. So if you like our videos, make sure that you subscribe and hit the bell icon. Otherwise, you will miss the remaining videos or the videos which I'm uploading recently. Okay, so I don't want you guys to miss it out. Please hit subscribe and hit the bell icon. We have 2 more exams I'm planning for the important questions of both of those as well. So make sure you don't miss those videos and catch them on time. All right, so moving on. Next is, this question had come up in the last year's term and examination paper, where they asked to compute the mean by shortcut method. Okay, so we know what we have over here is a continuous frequency distribution table. It is divided into class, so we need to find the class interval first, right? So what is the formula for finding mean in the shortcut method? According to finding mean in the shortcut method, we will take one reference point which we denote as A, okay, and then from there we are finding the mean, correct? So the formula is A plus sigma F, that is frequency, into D. D is the deviation from this what you can say, this base point or the point we have fixed, and divided by n. N is the total number of observations into your class interval. This is the shortcut means formula. So first we can find out I, correct? What is I? The class interval is from 0 to 10. So naturally I is 10. Next we can find n. N is the summation of all these frequencies, right? So this summation will give you n, and that n is 100. So we got these two. This is F, right? This is the F. We need to find out A. Now this is a class given, so we have to find the midpoints of these classes, and that will be our X, correct? So here it will be 5, 15, 25, 35, 45 and 55. This is X. Now you can choose any of these points as your A, okay? That is your reference point. For now, I am taking it as 35. There is absolutely no need for you to take it as 35 itself. You can try with any other point, but finally the mean should come same for both of us, okay? So I am taking 35 as my A. Now what should I do? I need to find out D, that is deviation. How do we find out the deviation? To find out the deviation, we have to subtract the X from this A and divide it by our class interval. Why? Because it is a continuous frequency distribution. So X minus A divided by I is your D formula. X minus A divided by I. So accordingly, I'll write down the D over here quickly. Okay, now I have D, I can find FD. That is, multiply D with the frequency to find FD. I'll quickly write down the FD as well. Okay, now I need to find the summation of F into D, right? So the summation of F into D, it comes to be minus 20. Now don't worry because there is a negative, okay? Absolutely no need to worry about it. Now this is the formula for mean. So let us substitute. Now I guess we have all our values. Let us substitute in this equation. A is 35 plus sigma FD is minus 20 divided by 100, that is n into I. Class interval is 10. So that is comes to be 35 plus minus 2, right? That is 35 minus 2. The mean is 33. This you should get no matter which point you take as your reference point or A. Okay, so this is how you compute the mean by shortcut method. Next is, assume the mean height of soldiers to be 68.22 inches with a variance of 10.8 inches. how many soldiers in a regiment of 1000 would you expect to be over 6 feet tall? So this kind of a question is similar to the Z-score questions you had in your assignment. Let us check how we can do this. 6 feet tall. 6 feet tall is equivalent to 72 inches. Okay, so we have to find out how many of 1000 samples you can expect to be above, that is greater than 72 inches. That is our question. And from the Z table, the area between 0 and 1.15 they have given. Okay, so according to Z table, we are assuming that the distribution is a normal distribution. Okay, this is your median. Sorry, this is your midpoint. This is your mean. So anything this divides the area of the binomial distribution or this normal distribution into two halves. Okay, here, and each of these, the total area will be 1, correct? And this midpoint is 0. So below 0, the area will be 0.5. Above 0 also, the area is going to be 0.5. And totally, you will get the area under the curve as 1. That is the generic idea. Now, we have been given the area between 0 and 1.15. 0 and 1.15, this is positive, right? So over here. So this area, they have given as 0.3749. That means if this is 1.15, the area below 1.15 will be how much? 0.3749 plus 0.5, right? So the Z-score of 1.15 is going to be 0.8749. That is what they are telling you indirectly. Now, we need to find out the number of soldiers in the regiment of 1000 who we are expecting to be over 7 feet tall, correct? That means we need to know what is our probability, what is the probability that the people will be over 7 feet. If you take one person, what would be the probability of that person being greater than 72 inches? Then you can multiply it by 1000 to get the approximate number of people who will be greater than 72 inches, that is 6 feet tall, out of 1000. Okay, so first we need to find out the Z point. Okay, how do we find it? For that, we need to minus the mean from the point which we desire and divide it by the standard deviation. Okay, so that is x minus x bar divided by standard deviation is the formula. That is 72 minus 68.22 divided by 10.8. If we substitute the values and solve it, we will get 1.15. That is the Z value is 1.15. So now we know the area under the Z the Z score of 1.15, right? We have already found out, they have given. One important thing, you are allowed to take your calculators. Okay, you are allowed to take your calculators while you go for your examinations to do these calculations. So don't worry about that. So now what do we need? We need to find out the number of people, this area, that is above 1.15. So what we have to do? We have to subtract this below value, that is 0.8749 from 1, the total area, to get this portion's area, right? So that is 1 minus 0.8749, that is you will get 0.12507 approximately. Now if you multiply it by 1000, then you will get the number of people who will be who we expect to be over 6 feet tall in the regiment of 1000 people. That is approximately 125 people we are assuming will be over 72 inches tall, that is above 6 feet tall. This is how you do such a question. Okay. Then another question. This actually came for a 20 marks, that is in section B, and that is quite shocking because this is a very simple question. The question is, a coin is tossed 6 times. What is the probability of obtaining 4 or more heads? What is the probability of getting at least 2 heads? Okay, so the coin is tossed 6 times, that is number of times the experiment repeated, that is n, is 6. What is tossed? A coin. What are the 2 possible outcomes? Either a head falls or a tail falls, right? 2 possible outcomes. So what kind of a distribution will this follow? A binomial distribution. Why? Because the success point is we get a head. Okay, so head is your success, and if you get a tail, that is a failure. So there is one success and one failure. That means it follows a binomial distribution. How do we find the probability of an occurrence? Okay, probability of an event, say x, okay, equal to r. Using binomial distribution, again this formula you need to study. It is NCR P raised to R Q raised to N minus R. Okay, N we know. What is P? P is the probability of success. What is success? Head. What is the probability in a coin toss for a head to come? Half, right? That is 0.5. What is the probability of failure? What is failure? That is Q. What is failure? A tail comes. That is also half, 0.5, right? So, the first part of the question is, what is the probability of obtaining 4 or more heads? When we toss 6 coins, it is asking us to find out probability of 4 or more heads, means either 4 heads, 5 heads or 6 heads. So that will be probability of x is equal to 4 plus probability of x is equal to 5 plus probability of x is equal to 6. Okay, that is 6C4 0.5 raised to 4, 0.5 raised to 6 minus 4. Okay, this is this one. Similarly, 6C5 0.5 raised to 5, 0.5 raised to 6 minus 5. And 6C6 0.5 raised to 5, sorry, 0.5 raised to 6, 0.5 raised to 6 minus 6. Now, if you substitute these values, if you solve for these equations, you will get the probability, and you add it, you will get the probability of obtaining 4 or more heads. The next is probability of getting at least 2 heads. Okay. So, what is the probability of getting at least 2 heads? Mean probability that x is greater than or equal to 2. That is same as 1 minus probability that x is less than 2. Correct? X is less than 2 means what? Either no heads or 1 head. So, that is same as 1 minus probability of x is equal to 0 plus the probability of x is equal to 1. Same way, x is equal to 0 formula will be 6C0, 0.5 raised to 0, 0.5 raised to 6 minus 0, and x is equal to 1 will be 6C1, 0.5 raised to 1, 0.5 raised to 6 minus 1, right? You solve for these two and subtract the whole thing from 1, you will get the probability of getting at least 2 heads. So, I hope the common type of practical problems you are now clear on how you can attempt. Okay, at least these 4 types please study and go, so that you get a better chance at working out these problems, because the theory part is actually quite limited. At least one of these type of questions we will have to know how to solve in order to get good marks, right? That is why. So I'm winding up this video. I will make one more video, that is part 3, where we will learn about the where we will discuss about the theory part of it. Okay, so see you in the next video. Bye bye.